the difference of square root. If I have binomial like this, x squared, or maybe just make it a squared minus b squared. If I have a squared minus b squared, that means you have a square quantity here and square quantity here. Yani something square minus something square. Okay? Then the answer will be, or the factorization will be, if I ask you to factor this, of course, the question here is to factor. Factor. Okay? How do you factor this? Okay, this will be a minus b, the first minus the second, and then the first plus the second. And we have seen this rule before, the difference of square rule, when we multiplied. Remember when I told you how do you multiply these two, you get this answer? Same thing. If I ask you to factor this, you give me back this. Right? So this rule should be in your mind. We can use it both ways. In multiplication, that direction, and factoring is that direction. Okay? But what is examples of square quantity? Yani this a square can be what? This b square can be what? Square quantity is squares of anything. Like for example, 4. Okay? 4 is the square of what? 4 is the square of 2, right? How about 9?
3.
It is the square of 3. How about 16?
4.
The square of 4. Okay, how about 25?
1.
The square of 5. How about a power 4? It's the square of what? A power 4 is square of what?
8.
A square, right? It's a square, all square, isn't it?
Yeah.
Okay, maybe we should have made a smaller example like a square is the square of what? The square of a, right? But a power 4, it is actually the square of a square. Okay? So let's do some more like this. How about a power 6, square of what? Is square of a power 3. This is the square of a power 3. How about a power 7? This is not square quantity. This is not square quantity. This is not square of anything that has an integer exponent. If you're looking at integer exponents, it's not. It is not the square of anything that has an integer exponent. Okay? So this is not square quantity. Okay? Type. If you look at variables, the rule is a square minus b square is equal to a minus b, a plus b, which means once you know this is the square quantity, this is square quantity, it is the first minus second, first plus second. And that's what we did. That includes both numbers and variables. Suppose, for example, I have 16 a power 4. This is the square of what? 4 a square. This is the square of 4a square. Okay? So if you have this example, how about the 1? 1 is the square of what? Of 1, right? Okay, so if I ask you to factor now, if I ask you to factor 16a power 4 minus 1.
So 4a.
It's easier to write it first as the square of 4a square minus 1 square, and then it becomes easy to find the answer. The answer now would be what? I just wrote this first as the square of 4a square, and I wrote this as the square of 1. So now it's the difference of square rule. Let's apply now the difference of square rule. How do I apply? What is the answer now?
16a, the same
4a square
Yes, 4a square
minus 1.
minus 1.
4a square.
4a square plus 1. Yeah, well, that's the rule, remember? That's the rule. That's what you did. You know, this is the square of this square quantity and this square quantity. So to factor this, well, it is the first minus second and then first plus second. So that's the idea, is to know it's the square of what, and then you'll be able to factorize. Okay? Let us now solve the question that we have. 36 minus b squared. How do I factor? Factor 36 minus b squared. Again, 36 is the square of what? Of 6, right? And the b, of course, is clear. So the answer would be what? 6 minus b. And this is 6 plus b. Simple as that. This is an easy question. Okay.